So you've been using VLANs to segment your networks for better management and performance. And as cyber threats have ramped up, you've probably added ACLs to secure your applications and data. But VLAN ACLs were just not designed for application security and are not as effective as application microsegmentation. For example, consider these two applications running in a data center. They are both three-tier applications with dedicated resources for each tier. To protect access to the data, we've placed the business logic and database tiers in a dedicated subnet-based VLAN. And the front-end web servers are placed in a different subnet-based VLAN. And there is also a dedicated VLAN for management systems. ACLs are then defined to provide selective access from the web VLAN to the backend VLAN, as well as management access to both VLANs. Now let's see how Colortokens can help identify vulnerabilities in this implementation and reduce or even eliminate ACLs using application microsegmentation. We've deployed the Colortokens agent on the various resources, and the Color Master has automatically grouped them by subnet so we can easily identify our two VLANs. This is the backend VLAN with the business logic and database servers, and this is the web VLAN. The traffic flows seem normal. For example, the web servers are communicating only with the business logic servers and not directly to the database servers. Now let's investigate how secure this really is. Colortokens has a built-in scanner that performs an exhaustive cross-subnet scan to identify vulnerable pathways. Let's go ahead and start a scan, and this only takes about 2 or 3 minutes to complete. Now let's examine the report. For each host within a subnet, the scanner performs a scan from a randomly selected resource from all the other subnets. And so, for each resource in the web VLAN, we have a scan from an arbitrary resource in the other two subnets. Let's look at the HRM database master. We see that it can be accessed on a variety of ports from the CRM web server. The access on TCP port 22 can be remedied by adding an ACL that only allows access from the management VLAN. The access on the MySQL port 3306 is more problematic, and this is a common issue with VLAN ACL-based segmentation. Because both applications share the same VLANs and ACLs, it allows the web server of one application to access the database server of a different application. It is just too cumbersome to add and maintain explicit ACLs for each resource. Now you could define separate VLANs for each application, but that also does not scale well. This exploit alone has resulted in numerous successful cyber attacks where hackers have infiltrated insecure web servers and have moved laterally to high-value assets. We will now implement Colortokens application microsegmentation to protect our applications independently from the existing VLAN and ACLs. I've already defined both applications in the Colortokens management system, and enforcing the segmentation is just a few clicks. Now, to look at the results of the microsegmentation, we don't need to run the probe again and can simply open the previous report. You can immediately see the difference. Ports that were previously accessible from undesired VLANs have been blocked as a result of Colortokens microsegmentation. So we can remove the ACL rules relating to these VLANs as they were not very effective anyway. And that's how Colortokens can help you audit and optimize your VLAN ACLs while providing better security through application microsegmentation.